All right, so we're going to still talk about area. We talked about area of a rectangle or a square. We're talking about irregular shapes right now. So if we want to go over and we want to think about area, right? There's a couple things we want to keep in mind. So area is the inside measurement or space inside of a shape, and we find it length times width. And if we think about a square, square has 4 equal sides, meaning all sides are the same length. And a rectangle also has 4 sides, but the opposite sides are the same size, okay? So if we keep those things in mind, when we look at irregular shapes, I want you to think in the back of your head, squares and rectangles, okay? So we see this and yikes, oh my goodness, it's not, right? We have all of these different, numbers everywhere. But if we think, okay, this would be a rectangle if this little chunk was here, right? If we drew here, that would be a rectangle. So if we said, all right, what do we know about a rectangle, right? So they gave us some information here. They said this whole, length is the 8 feet. The width is 6 feet, right? Over here they said it's 4 feet. This is 7 feet, 2 feet. Oh, they didn't tell us what this was, man. But again, not that hard. If we think of a rectangle, rectangles have to have opposite sides the same length. So if we come over here, right? Opposite sides. And so notice I use different colors to help me remember what my opposite sides are. This is the unbroken line, okay? The opposite side to that would be this side and this side, right? That's my opposite side. So if the total has to be 8, because this is our whole unbroken line, so this is 7, so what does this have to be? Right? 7 plus 1 equals 8. So now we know what that piece is. And if we look, right, here's our unbroken line, 6, right? If we look at our other blue opposite sides, here's 4 feet and 2 feet. 4 plus 2 is 6, right? So we know. So now, if we want to try to solve this problem, right, we know all of the side measurements. Now, try to break this shape into 2 different shapes. So then it's easier to find. That's why we do it. That's why we break it up, because it's easier to find the area, right? We can make 2 different rectangles, find the area of those rectangles, and then add them up, and we would know, okay? So we're going to take a few minutes to try to solve problem 1. Think about how you're going to break it up. Hit the pause button and work on that problem. And when you're done, come back and see how you did, okay? All right, so there were 2 different ways you could have done this. You could have broken up the shape this way. So you have shape A and shape B, right? So you might have done that. Now the point or the next step is to figure out which, sides are we going to use. So I always like to say, if you're using the 2 different colors, right, you can use 2 different highlighters, you could use crayons, colored pencils, right? You're multiplying 2 different colors, okay? So here's a red for my A. Now here's a blue and here's a blue. So how do I decide which blue to use? Again, I look. If I use this blue goes into this over here, right? There's that line I broke it up into. So I don't want to use that blue. I want to use this one. This one's a complete line. All right, so I would do 8 times 4, which is 32 feet. And then my B is this shape right here, 2 feet by 1 foot. All right, so 2 times 1 is 2. So the 32 plus the 2 would be a total of 34 feet. Now, you might have broken it up a different way. You might have broken it up this way, right? And again, okay, shape A, shape B. So I have to figure out, oh my goodness, A. Oh, I see a red, I see a blue. Which one do I use, right? So over here, this is my unbroken line, but look, my other shape goes through it. This one doesn't. So here I want to use the 7 and the 4, okay? And that's why, because see how this 8 goes up into this shape. We don't want it to go into the other shape. All right, so this is the complete shape. So we say 7 times 4 is 28. And on this one, here's our 6 feet, and our 1 foot, which is 6 feet, we add them up, and the total area is also 34 feet. So it doesn't matter how you break it up, you should get the same answer, okay? So let's try problem 2. All right, so if we look at this shape, right, you want to think about opposite sides are the same size. Opposite sides are the same size, all right? So let's look, because there's some things that are missing, some measurements that are missing, okay? So, all right, here is 7 inches. Now again, I'm using different colors so I can see that these are my opposite sides, okay? So if this is 7 inches, my opposite has to be 7. So if this is 3, what does this side have to be, right? 3 plus what equals 7? It should be 4, okay? So now let's look at our width here. So I have 6 inches, all right? And again, opposite sides have to be the same, so it would have to equal 6. So I have my red, I'm going to go, this is 3. Oh, we don't know what this is. Well, 3 plus what equals 6? 3. So now we have all of our things, measurements, not things, our measurements, our sides measured and labeled. All right, so now we want to try to solve the problem. We want to find out what the whole area is of this problem, of this shape. So now start thinking about how could you break this shape up into 2 different shapes, okay? All right, so you're going to take a few minutes to try to solve problem 2. Hit the pause button, and when you're done, come back and see how you did. All right, so problem number 2. We had said that this was 3 and this was 4, right? So you could have broken it up this way, right? So you have a square and a rectangle, or you might have broken it up this way. So again, let's say we did it this way. And okay, again, we want to do 2 different colors. We're multiplying the 2 different colors, right? The length and the width. So do I do the 6 in the 3 or the 3 in the 3? Right? That's where kids start to get confused. So again, if I think about, oh, okay, the 6 is part of 2 different shapes, right? It's part of this shape and it's part of this shape. So we don't want to use the 6 in this case. The 3 is only part of this shape, and this 3 is only part of this shape. So we want to do the 3 times 3, which is 9. And then over in this rectangle, again, we have a lot of numbers. We have the 6, we have a 7, right? We have a 4, we have 3. Oh my goodness, which ones do I do, right? So we have a whole line here, 7. And again, do I use the 3 or do I use the 6, right? Well, again, this 6 is going into the 2 different shapes. So I don't want to use the 6. This 3, right, has to go only with this shape. And again, I'm doing 2 different colors, right? Here's my blue and my red. So we don't have to worry about the 4. So 7, here's my, length and my width. 7 times 3 is 21. So altogether it's 30. If you did it this way, again, super. But again, now we have to figure out which lines are we going to use. All right. So can we use the 6 this time? Yeah, because that's whole shape, right? And so, here's my 3. So 6 inches times 3 inches, 18 inches. And then over here, right, I got 2 blues and a red. So which blue do I use? Well, the 7 is in both shapes. We don't want to use the 7. The 4 is only in this shape, and the 3. So 4 times 3 is 12, and again, we get 30 inches. Okay? So it either way, you should still have come up with 30 inches. All right, let's look at actually, before we go on, if you're having any confusion or questions, or you're not sure about something, jot down the questions right now so that you can ask, we gather up together, okay? All right, now let's look at this one. All right, so again, remember, we're thinking squares and rectangles because this looks like it can be awfully intimidating, right? So, and if we think about squares and rectangles, squares have all the same same size sides, right? Rectangles, opposite sides are the same. So again, I'm using my different colors. All right, and this one's broken up into a little bit different. So I always try to look, all right, here's my solid red line. Okay, I made it red. You can make it any color. So my opposite side is going to have to equal 12. Okay, so here they gave us 4 inches, 4 inches, and mystery, right? Well, 4 plus 4, what do we need? We need another 4 inches because that would equal 12 inches. And then if we look at our blue, oh, we don't have a solid line. Okay, question mark, oh, question mark, right? 5 inches, 4 inches. Well, this has to be the same. 4 inches, 5 inches, okay? Now, I want you to try to break this up and see what you come up with, okay? So, take a few minutes to work on problem number 3. Hit the pause button now when you feel good, when you feel like you completed it, you've checked it over, unpause it and see how you did. Okay. All right. Let's see how you did. You could have did it. You could have, well, I think this would probably be, you could have broken it up into actually a few shapes, but to do 2 shapes, we made the line over here. Okay. So we have this big shape, this rectangle, and this square. So again, I think the colors help. So if you're thinking I'm multiplying, I got to have 2 different colors when I'm multiplying. So I see a lot. I see red, I see red, I see red, I see blue, I see blue. The blue, okay, the blue is 5 inches, so we know it's 5 inches. But do I use the 4? Do I use the 12? Right? So if I think about it, the 4 is only going up to here. So the 12 is all of this shape, and the 5 is all of this shape. So if you do 12 times 5, 12 times 5 is 60 inches. If I look at this shape, right, I got a lot of different colors here too, but I have 4 and 4. Okay, so side, 4 times 4 is 16. So I take the 60 plus the 16, and I have 76 inches. All right. That one was a little bit difficult. So now, if you got that one, fantastic. If you didn't, look at where did you do something different? Okay. Did you use different numbers? Did you make a mistake on which sides to use? Look at where your mistake was. If you did it a different way and you still came up with 76 inches, please either tell me in the comments, tell me in the classroom, share, because I would like to see how you did it, because there's definitely more than one way to do this. This was just probably the most efficient way. However, there's more than one way to do it. So, all right, let's look at problem number 4. All right, so there's some missing sides again. So again, if we think about, okay, this is obviously a rectangle, the opposite sides have to be the same size. So let's think about that first, because we have some missing, lengths. We have this piece is missing and this piece is missing. So here's a solid line, that's 4 centimeters. So my other blue, right, has to equal 4. So if this is a 1 centimeter, then this has to be what? 3, right? Because 3 plus 1 is 4. So that would be my whole line. Then this whole side is unbroken. This is 3 centimeters. So that means my 2 reds have to equal 3. So if this side is 2, then this side has to be, got it, 1, because 2 plus 1 is 3. All right. So now, that's right, you're going to be pausing and you're going to try to solve this one. This one's probably the easiest of all of them as far as numbers anyway. Think about how you can break this up into 2 different shapes. And again, there's a couple ways to do it. So let's take a few minutes, see how you do. Okay, so hit the pause button now. And when you're ready to check your answers, unpause it and see how you did. All right, let's look at problem number 4. So we figured out what our missing sides were. So you might have broken it up this way, where you have this rectangle A and rectangle B, right? And again, 2 different colors, but I see a lot of different colors here. Which ones do I choose? All right, well, the 4 seems to be pretty easy, but I see a 3 and I see a 2. Which one am I using, right? So how do I make that decision? Well, the 3 goes up into 2 shapes. Remember, I want my side to only be part of that shape. So this is why I picked the 2. Okay, so we have the 4 times the 2, which is 8 centimeters. And then when I look at this shape, right, I have the 1 centimeter and the 1 centimeter. And 1 times 1 is 1, so the total would be 9 centimeters. You might have broke it up this way. Okay, so we have shape A and shape B. And again, I see a lot of different colors here. So do I use the 4 or do I use the 3? Again, I say to myself, which one is only part of this shape, right? The 4 goes into both shapes. This 3 is only part of this rectangle. So the 3 times the 2, which is 6. And then if I look at this shape, here's my 3, right? You could say, oh, do I use the 4? But again, this 4 goes into both shapes. So we don't want to use the 4. So we use the 3 and the 1, right? And 3 times 1 is 3. So 6 plus 3 is 9 centimeters. So again, it didn't matter how I split it up. I should still get the same answer. All right, so those are our 4 problems that we wanted to try today. Some helpful hints to remember when you're thinking about area of squares and rectangles and irregular shapes, okay? Here, it's good. Think squares and rectangles. You could use 2 different colors to help you visualize the opposite sides. So either highlighters to highlight the 2 different sides, or different color pencils, crayons, markers, whatever. Try to split it into 2. I would say try to do it to 2 shapes, but sometimes, 2 or more, squares or rectangles. And then once you have split up your irregular shape into squares and rectangles, find the area of all of those shapes and then add them up. And then if you get confused about lines, I don't have this on here, think, does that line just stay within this shape? And then at the end, remember to always label all the measurements, if it's feet, yards, inches, centimeters, etc. Okay? All right, so any feedback you can put in the comments. Any questions you can put in the comments. In class, we'll discuss. And I hope this was helpful. Thank you.